Okay, share the screen. Okay, everybody can see my screen? Hello?
Yes.
Yep, you're good.
Okay, so this is spring 2021, right? Here's 2300. If you go into the learning units, you will find that, there is syllabus. And from the syllabus, you will find the PDF of the syllabus. And from there, you can just read, the information about the whole entire information about, the chatting and so on. So let's go through it. So what is exactly we are going to learn in this course? Have you heard about something called digital logic design? How many of you heard about binary system?
Binaries? Oh, no, man.
Okay, so you guys will be able to read and convert different number systems. So, at least for the chapter 1, we are going to discuss about, what is the binary systems. And by the way, binary system is a computer language. It's a machine language, which is a bunch of 1 and 0s. So everything in a computer is based on there is a charge, there is no charge. There is no charge, it stands for 0. There is a charge, it stands for 1. Then combining bunch of 1 and 0s will be coming into another number system, which is called hexadecimal. And if you notice, I'm not sure how many of you guys have been working with the C language and, coding with C. Have you guys tried coding with C?
Yep. Yeah.
So in coding, while you are coding with C, right? Tell me, at the end of the day, you write somewhat hexa. So you put hexa numbers and you put masking, and then, you will move for shifting and rotating and all this information, right? So you're going to learn a number system called hexa. There is other number systems, which is almost infinity. When I say infinity, there is a octal, there is hexa, and also there is the one, we learn in high school, which is a decimal, right? So everybody know how to use decimal. So one of the other things that, you're going to learn out of this course, everything in the computer is adding. What does it mean? So, we learned before that, there is addition, there is subtraction, there is multiplication, there is division. And then, combining this together, we're going to do integration and derivations and all of these things, right? But we're going to learn in the chapter 2 and chapter 3 that, everything is belong to adding. What does it mean? So if I would like to subtract, it's actually adding. If I would like to multiply, it's basically adding and shifting. If I would like to divide, it's basically adding and subtracting is actually adding. So basically it will turn to be adding and shifting. Okay. Then we're going to learn how can we move from a number system to another number system. And what is the advantages of every single number system. Then we will move to something is called logic gates. How many of you guys heard about logic gates?
I've never heard of it.
Okay.
I just heard of it.
I heard of it. High school.
Yeah, it's basically there is a bunch of basic gates, and some basic gates, you use it advanced to build a bigger gates. What does it mean? So for instance, the basic gates are called and or and not gate. And or not gate. Then if you use the not gate after the or gate, that's actually called NOR gate. If you use the not gate after the AND gate, that's combined together called NAND gate. Then combination between OR and NOT gate and AND gate, you can have something that's called XOR gate and XNOR gate. And out of this, we're going to learn something that's called truth table, which is a way of combining a relation between the input variables and the output variables. So if you have a block, and this block, you don't know what is exactly is doing, what is the behavior of the block. So you're going to study the input and outputs, right? If you make a relation between input and outputs, people in control system, they call it transfer function. Okay? If you try to study the relation between input and output in something you don't know what is this, it's called transfer function. For us, it's called truth table, and we're going to learn about it. So we will move the gear into something called combinational circuit versus sequential circuit. So what is those? So combinational circuit is a circuit which is not related to the time. So you put the input, you will wait a little bit for the time, and you will get the output. I didn't make why this code was more general focus on just this class, but either works. Okay, I'm gonna tell you more about what we're gonna use. Anyway, so the combinational circuit is basically, it doesn't have a timer. If you involve the time in the circuit, you call it sequential circuit. So we're gonna study combinational circuit, sequential circuit. What type of element of sequential circuit we are using, what type of element of the combinational circuits are using, how we gonna combine together some elements to build a bigger circuit. Then we will come into a conclusion combining combinational circuit with sequential circuit together, gonna build for us something called memory. And combining them together will build for us something that's called ALU, which is a stand for arithmetic and logic unit. It's a unit dedicated for adding and subtracting and multiplying and dividing and shifting and rotating and all of this info. Then combining everything together, we're gonna build a processor and so on. So the course description, we're gonna learn the analysis and the design of both combinational and sequential circuits, which coming from full understanding of the numbering system and the number system theory. To be qualified to move forward with these materials, you should take the 11.1 and its lab, or 13.10, and of course you're gonna take the lab dedicated for this course, which is 2300 lab. Okay, this course is going to be, we're gonna have 2 meetings per week. It's gonna be Monday, Wednesday, 1 o'clock to 2:15. Okay, today I don't think I'm gonna stay until 2:15. It will be too much for you. I will also do my best to finish everything, maybe give you 10 minutes before you will move to the next class and so on. Okay, on the top of that, I'm going to create a recorded list of every single lecture I'm actually giving you, and I will put it on YouTube. Then I will leave the link in a PDF under the week number. So if you notice here, right, here is learning unit. In the learning unit, I already made it multiple folders. Each folder is by the name of the week. So for instance, we are in a week 1, right? So if you click in a week 1, you will find that there is supporting material and there is recorded lecture. So our lecture today will be under the recorded lecture, and I'm gonna make the name of the file with the date of the lecture. That makes sense? So if you have time to look at the materials, if you didn't have time to attend the lecture, or whatever you like to actually review, check something you already missed and so on, you can go ahead and check it from the week under the week recorded lecture. Let's say that I have like a supported material. You will look at it, you can study more out of it. I can just put it there. That makes sense?
Yep.
Any questions so far? Huh?
Yes.
What?
No question at the moment.
So far so good. Okay.
Yes.
Now,
Thank you.
Now we are going into what we're gonna use the Zoom room, which is this the ID number, and all of you actually are using it. And here is information about the whole entire thing. If you cannot access through the computer, you can access through the phone, and all of this info you can find it there. So let me see. Okay, let me see. Somebody say missing something, so I need to reply back to them. Okay, anyway, now my name is Muhammad. So actually my name is Muhammad El-Hadedy, but I use my name to be Muhammad Ali. It's much better, easy for you guys to pronounce it. So if you look to all of my scientific research, you will find all of my manuscript and publication under Muhammad El-Hadedy. Okay, if you regarding calling me, you can just call me Dr. Ali. Okay, and basically my office hour are going to be on Monday, Wednesday. My physical office is actually room 131 in building 9, but I know unfortunately everybody can actually go to the campus due to the pandemic and all this information, except me, by the way. I'm sitting in my office. So if you guys would like to talk to me about something related to the course material, related to the lectures, related to the homeworks, or many other problems you actually are facing, or whatever, on Monday, you have time dedicated for this from 11:30 to 1 o'clock. And then, there is a break because I'm going to be teaching some other stuff. Then, at 6:45 p.m. to 7:15. So you have a window of 2 hours per Monday. If you have any questions, you can access, to the Zoom, and, but before you will do this, you're going to go into something that's called Calendly, and you're going to book like a slot of time there. Okay. Which is basically, every time that we're going to be discussing, it's going to be 15 minutes per student. Okay. Same thing also for Wednesday. So Wednesday is 11:30 to 1 p.m. and 6:45. 1 second. 6:45 to the 7:15. Okay. If you also have any questions that and you don't have time, or maybe some time of conflict, or you'd like to reach out to me, this is my office number, 909-869-2594, and this is my email address, which is maily@cpp.edu. Okay. So what is exactly we're going to learn out of it? So, let's say that, I decided to go to attend the class of 2300 with Dr. Ali. What I'm going to learn out of it, besides I'm going to get a grade, of course. So you're going to learn what is the logic mean? What does the digital logic gate mean? What is the logic equation it is? What is the truth table it is? And how can you read the timing diagram of a combinational circuit, and of course, a sequential circuit? Then you're going to learn about how can you make an optimization. How can you use less resources or elements to build this combinational and sequential circuit? In the top of that, you're going to learn something is called DeMorgan Theorem, which is one of the optimization techniques they are using for decades in something is called CAT tools. So whatever you're learning now, there's tools already using machine learning and AI are doing it without you knowing what's going on, behind the scenes. Okay. Then you're going to learn how to make a combinational circuit example, like, multiplexers, decoder, encoders, demultiplexers, majority encoder, majority decoders, and all of these things. And on top of that, you will be able to build comparators, adders, multiplexers, subtractor, dividers, whatever. Then if we have time, which, we don't know yet, right? We have 15 weeks window. I can give you some info about one of the languages used for writing and describing hardware. So what is this exactly? So imagine the following. You are taking material from the 2300, right? And now we are going into the 2300 lab. So they're going to ask you for what? For a breadboard, right? And in the breadboard, you're going to bring a set of ICs, right? And then you will start putting wire around, to connect it to the ground, to the power and all of these things. Then, the LED will be turning on, or maybe the speaker will be running, or, microphone is actually receiving some noise or sound, like human voice, whatever coming from somewhere. And then you will be able to actually outputting it on the speaker. I'm just giving an example, right? You can actually do this on different environment, which is called field programmable gate array, which stands for FPGA. Or you can put it on some ICs instead of having multiple ICs with wire, and that will be called ASIC, which is applied customized circuit. How can you do this? You're gonna learn a language is called Verilog, for instance, which is one of the hardware description languages. Or you can learn VHDL, which is also another one of the hardware description languages. And the third one is called System Verilog. So there is a course after the 2300 will be dedicated for Verilog, which is named by the 3300. Okay, so after the 2300, so that's why 2300 is very important. I want you to learn every single info out of this course. It will help you in the, sorry about that, 3300 lab. And then, once you will get the knowledge about 3300 lab, you're going to move to the 4304 and 4305, and of course the 4300, which is the computer architecture. So this course is like the base. If you learn the basic information out of this course and you have it very strong, you can move forward up without any problem. That makes sense? Then that's the rest of the information if we can learn out of it. If not, there is a room, of course, in the 3300 to learn about the hardware description languages. What type of books we gonna learn? Let's see if somebody's messaging me. Let's see, reply. What type of materials we're gonna use, right? So there are two different materials. And honestly, to be honest with you, there is infinity number of materials you can find in internet. Digital logic design is something have been well known for decades. I'm not inventing something new. Maybe I can teach you some tricks I already made, but it is something exists. It's like, 1 + 1 is equal to. It exists without, me telling you that I invented, it's 1 + 1 is equal to, right? So one of the book, it's for one of the colleagues here at ECE department, Dr. Rafiq Zaman, and it's called Digital Logic and Microcontroller, which is a current edition you will find in Wiley. Or, the one which I actually prefer, which is actually for Maurice Mano, which is called Digital Logic. By the way, this book, you can find a PDF on internet. Okay? Before I can go to this, I have a question to you guys. Do you guys like me to create like a channel? So like a channel on like a Slack. I prefer Slack. So I can show you what I have here. So for instance here, look, Slack. And I already created multiple Slack. Here's for Fermilab, some for some defense contractor, but this is for you guys. I call it RICO IoT, Reconfigurable Internet of Things. So everybody can see my my screen.
Will you be active on that Slack?
I'm active all the time on Slack. See, even I have some students, and we work together on it. Okay.
Yeah,
so,
I prefer Slack.
I like Slack because Slack is used by the top companies like Microsoft, Amazon, and Intel, Xilinx, IBM, and all of those guys. I know that you guys like Discord, right? I think so, but
yeah.
I'm not sure why you guys like Discord. That's something I don't know. But for me professionally, I like Slack. Okay, so last semester, fall 2020, I made them, the set of courses that I was teaching, plus some NASA projects, an IBM project. I already have Slack for them. So here, for instance, 2300, right? I gave them a copy of the book. So there is a link actually for the copy of the book. Okay. So what I can do, I can add all of you guys' names there in the ECE2300 _ spring 2021. You guys like this?
Yes, that'd be nice.
Yeah.
I think that's actually fair enough, right? So what I can do, I can do it now, and then you guys can just go ahead and we can start discussion. So for instance, I also post some scholarships, I found some internships, stuff like that, like one of this NASA Minds. And by the way, my team actually now in the NASA Minds building a drone, for instance, So that's why I was posting it for the 2300 people before you. And they're doing a really good job now. Anyway, so let me create a channel. Let's see how can I create a channel. So here, create a channel. And this channel, I will call it ECE2300 spring 2020. Everybody can see it, right?
Yes.
Description, activities belong to ECE2300 class for spring 2021. Okay, then this cannot be undone. A private channel cannot be made public or later. Make it a private. We can make it private. And let's see, somebody messaging me. Today everybody's messaging me. I don't know why. So okay, now we already have it, right? So we have the channel. So we need to start adding you guys. So what I can do, I can just go here to CPP and take a list of your emails and add you.
Oh, there's not like a link that we can click?
No, it's by invitation.
Oh, fancy.
See? Yeah, it's tricky. Security, I'm a security person.
Makes sense, makes sense.
Yes. What the heck?
You probably have another tab open already.
Yeah, let's see. Okay, yeah, sign out, sign in. It's not really smart link, so anyway. Scheiße. Anyway.
That really sucks.
No, don't worry. I know what I'm gonna do. I will just go like this, close all of my links, even I'm writing some stuff, but doesn't matter. Close
Struggles.
Yeah, it is what it is. So anyway. Okay, let's close all of the Lambda. Close of the Calendly grants. Google, open Google, Captain Google, and then I just go and say share screen again for you guys so you can see it, right? So now here I can say Slack. I go in a Slack like this and go like this Rico. And we are this, right? Then I will go here CPP. It should be fine. I'm gonna go here and say login. It should be okay now. Then I go here in faculty center. From there I can stop like this. You are 2300, right?
Yeah.
And what I can say, I say notify all the students. Then I can take a copy of you guys like this. Boom. I added there. How can I add people? Add people. So add to the EC, add new member to existing channel, create a new channel. No, just this one. And then I put you like this. Then everybody can see his name, right? So.
Oh, we gotta do it through CPP. Okay.
Yes. No. I can actually add you as a private email. That's fine to me, but and then I can say here add. Okay, that's it. I need to see something here. Okay, now 33. So you guys will accept it, okay? Every time somebody will accept, see the number will be incremented. That makes sense? Okay, now I can go ahead like this and give you the copy of the book. Okay, we can click on it. Everybody can see my screen. Take some time. It's very slow, but it should take. Oh. Let's see, wait. What we can do, I can just get a new link. Digital Logic Maurice Mano.
I think I put the book.
You put it? Did you find it? Yeah, here. Here we go. Okay, so now everybody have the material. Now we will go back to the rest of the syllabus. So let's go to the syllabus. 2300 learning units syllabus. Open that. Okay, so the Manu book, right? It has a multiple chapters. So first thing we're gonna start is gonna be number systems. We're gonna go through the number system as I mentioned before. After that, we move to the next chapter, which is called Boolean algebra and the logic gates. Then after we fully understand how the logic gates work and how can you actually add them together and see what is the output will be, we're gonna go into the analysis and the design of the combinational circuit using this logic gates we learn, which is basically you have to learn the truth table, timing diagrams, sum of product and the product of sum realization, which stand for SOP and POS. And of course, we're gonna learn the what's called the magic map, which is called K-map. It's for one well-known mathematician who already invented specifically for the logic gates. And then, there is some word-based problems we can actually play with. And then we're gonna go into the implementation for the combinational circuit. So we're gonna learn about what is the comparators, how it works, decoders, encoders, multiplexers, what is the difference between half adder versus full adders, binary adders, subtractors, and the PCD, and the combinational shifters. Then we will move into how to build ROM, which stands for read-only memory. What is this read-only memory in life? Somebody can give me an example for ROM.
A cartridge in a gaming console.
I will tell you something. Every time when you open your computer, right, you will get a weird screen, right? And this screen will tell you, this Samsung, whatever, or this computer is Dell, right? BIOS. Have you guys heard about BIOS? BIOS.
Oh, yeah.
This is the BIOS, it's ROM. But this ROM, it can be rewritten in a different environment. So they call it EPROM. Okay. Then we have the sequential circuit. Of course, we're going to learn about it. What elements we are using sequential circuit. The first element we're going to talk about is coming from the combinational circuit, which is basically latches. Then we're going to figure out latches already have some issues. Then we're going to move into adding latches together to build something that's called flip-flops. Then we're going to learn about, how can we identify the behavior of the flip-flops by learning something that's called characteristic table, transition tables, and excitation table. Then from there, we're going to learn how to build synchronized circuit and asynchronous circuit. Then we're going to build counters, and we're going to have some information about what is FPGA, as it will be introductory for you before you will go to the 3300. And from there, we're going to be ending the whole entire material of the 2300. Let's go now for the parts maybe you guys don't like or you like, but last semester everybody actually was doing really great with this course. So I hope that this semester you guys will do also great. So for the evaluation outcomes, to evaluate whether that you guys already digested all of the information that I already shared with you, and whatever you also found out even from outside sources, we're gonna have 2 midterms and 1 final exam. Before I used to have many quizzes and midterms and so on, but I don't want to be too much on you guys, as I know it's a pandemic and a lot of headache, and everybody, of course, like not in a great shape. So we're gonna have 2 midterms. Each midterm will be taken 25% as a credit. Okay, so eventually, you will find that here in Grade Center, I'm gonna divide this into like 3 columns plus the final and all of these things, and you guys will find all of the grades written there under the Grade Center. Okay, how are we gonna have exams? First, what are the dates for our exams? Our date of exams, the first one is gonna be week 7 on March 10th. March 10th, it will be, I believe, Wednesday. Then the second midterm will be in April 14th. That should be before or after, I think. I don't know. It should be before or after this spring break.
Professor, I have a question.
Sure.
Based on the rubric you have right now, it's saying that everything's all exams. Are we gonna have any homework grading?
No. I will tell you why. Homework, it's school thing. I'm gonna give you homework for sure, right? But the problem with homework, I'm not talking about a specific person. It's a party. You will go in Discord. Everybody will pass the homework to homework. End of the day, I cannot honestly give somebody a grade out of it. But of course, I'm gonna give you homework. You need to do the homework. It will help you, of course, with the midterm. But grading it, I'm not gonna grade it. Okay.
Will you also post the solutions so we can know what is right or not?
Oh, of course, definitely.
Okay. Yeah.
Okay. Now, the final would be around 50%, and that should be based on the university schedule link, right? How are we gonna have exams while we are in the virtual life? So I use something that's called Grade Scope. Have you guys heard about it?
No.
No.
Okay, so Grade Scope, it's I can show you. So here, Grade Scope. Here is my Grade Scope account. So I will create like a see, some people, you shouldn't see, but anyway, I'm gonna create here like a new course, right? Which is a 23_spring 2021, right? Then I'm gonna post here the first midterm on the time. How long you have ability for actually solving the problem on the midterm? Before, we used to have limited time. Do you guys remember? We just have like 1 hour, 1 hour, 15 minutes based on the time, right?
Yes.
No, in reality, we're gonna have it from the from the 8 a.m. of the day of the exam till midnight. So you have a long time to solve the problems and put it on the Grid Scope. My exams is not just like 1 hour. I know that you guys also have other stuff to do, right? So I'm gonna start the clock 8 a.m. and ending midnight. Then within this time window, you have the ability for loading your answers. Sounds good? Then the day after, I will have the list of the solution that you already guys made, right? From there, I will start grading you. And of course, I will be writing why the grade look like that for every single breaking question. Then I will release it. So every single student will see all of the comments I made with the grade. If you have any questions, maybe I made a mistake in calculating or whatever, you can come back to me during the office hours. We can discuss and see what are the problems. Every time I will make a midterm, the lecture after, I will be solving the midterm. Sounds good?
Professor, quick question.
Sure.
Just to make sure I have this right. So for the midterms, we'll have so Is it like when we start it, we'll have a time period, or even when we start it, we'll still have from 8 to midnight?
No, it depends. Let's say that I made it 8 a.m. The folder in the Blackboard, which is associated to the grid scope, will be released. So you will be able to access from 8 a.m., right? Let's say
Okay.
that, you decided to start solving the problem 8 a.m., right? You finished, right? Let's say you finished 10, 11, noon, 1 p.m., up to midnight. You are fine. Then, submit it.
Okay.
There's not just like 1 hour and you're done. It's the whole day for you.
Okay. All right. I think I get it now. Thank you,
Much
Professor.
better, use the computer, because we are actually, most of us, computer engineering. Of course, I have some electrical engineering, and I actually am electrical engineer. But I like you guys to use the computer writing nice way, because this is a very nice practical way or training before you will join industry, or if you're gonna go apply for internship as well.
All right.
And also there is some software later on I will share with you to draw the gates instead of, using your hand and all of these things. Sounds good?
Sounds good.
Graded, send it to you. And also you will find in the grade center, so you will be able to see, oh, I did really bad in this midterm. Oh, I did a great job in this midterm. Oh, I have this amount, so maybe I have to. So you can plan ahead what you're gonna do for the next one, so you can make your own strategy. And I can help you with a strategy if you want. Sounds good?
Sounds good.
Okay, so now let's move to the grading scale. So the Calpoli Pomona, they have a fixed grading scale, which is basically, if you succeed on counting to 93% to 100%, you will be defined as A. If you are 93 to 90, you are A minus. Of course, if you are 93, I'm gonna look to A, not A minus. I'm not gonna put it into the lower one, right? Maybe I can do rounding also. It depends on how it looked like, right? And the B plus and so on and so on. But if you didn't reach 60%, you will be considered, unfortunately, as a F. Okay. So of course, some general rules, and everybody know, there is some way of asking questions about, oh, maybe I deserve better result or something like that. Yes, it's acceptable, but some, I'm not saying anybody here, but, sometime, occasionally, you will see some negotiation. And, I don't like negotiation. Yes, scientifically, if you prove to me that, there is something wrong, of course, no doubt, automatically it will be corrected. We are humans, I'm not a machine. But let me tell you a story. Grade scope, I already have an AI model there. So it's automatically will figure out who is cheating. And it will list them out to me and say, oh, this one took from this one took from this one. And it will start making a big map with propagation. So be careful. You have to dedicate the time for yourself. You have to do your best in the solving problems in the midterms and the finals. This is your life. Maybe you can get A, but in the future, this A will be nothing. Nobody will respect it. So I would rather get B or B minus than getting A. But if I go to the what's called hiring manager, and then he asks me a question I cannot answer, that's not really, really nice. Okay. So far, do you guys have any questions?
The homework problems that you're going to be giving, are they based on the exam? I mean, not based on the exam, based off of the textbook?
Infinity resources, but the textbook is like a base. So, this is something maybe different for majority of you. In a college, right? We are not actually, how to say, we are not just limited by one book or one source, but the source is a guidance. Like, the book itself is like guiding you. For instance, K-map in Morris Mano book is exactly as Rafiq Zaman book. But, there is some problems in Rafiq Zaman. It's not actually exist in Mano. This problem in Mano is not exist in Rafiq, right? There is even some problem is not exist in Buzz book, but, somewhere else. But if you know the regulation and rules and steps, right? It's a piece of cake for you, no doubt. That makes sense? So, of course, I'm going to bring you some homeworks. It can be from the book. It can be from other resources. But, of course, I can go through all the homework with you if you have any questions. And in the top of that, as I mentioned, every midterm, once, the grade is actually released, I can go the next lecture and actually solve it with you one by one. And sometimes I do like a race. So basically, while I'm solving, if somebody give me like an extra trick or maybe a new way of actually solving it, I can give him extra points. I appreciate creativity. Okay? This is not a real math. That's not math. 1 + 1 here is not actually equal 2. 1 + 1 here is equal 0. Do you know that? In binary life, 1 + 1 is not 2, is 0. And then you have something that's called carry, which is 1. Anyway, so far, any questions? Okay, the last thing I need to mention before we start is going to be about the wait list. So far I have around some 30 thumbs. So due to the capacity of the class, I don't think I will be able to take more than 3 more students. So from the wait list, the first 3 students, I will just send them a permission number after the class will be over. I would love to take all of you guys, but the problem that we are limited here, and the problem that I do also grading and all of these things by myself. So take some time, I hope that you guys will, you understand that. Sounds good? Any questions? Any concern? Hello?
Yeah, just a quick question for the homework. Is there any like submissions or anything like that we need to do, or?
How are you gonna do it? This is very interesting. So basically what I'm doing, I'm actually gonna create like either GitHub account.
Okay.
And then, I give you an access. So it will be even a good practice for you to play with GitHub.
Yeah,
How many of you heard about GitHub? So, I try to put everybody in my team in the right track. So for instance, GitHub here, look, TensorFlow. So basically, I can show you an example. So, excuse me. For my research at Cal Poly Pomona, I create 2 different GitHub. One is called Reconfigurable Cal Poly Pomona, Reconfigurable Computer Cal Poly Pomona, and I put there all of my research project. But there is another one I made it for teaching. See, like 3300, whatever. And then you put your, I will dedicate a folder, so you will just dump your solution there. And then this is a private one, so nobody can see it. Why I'm doing this? This is an extra credit. Imagine that you're gonna put like a line written in your resume, say that I'm aware of how to use GitHub. Very appreciated. Sounds good?
Yep, that's great. Thank you.
You're welcome. Any other questions, guys?
I think just regarding the GitHub thing, I found a pretty sweet tutorial online to kind of teach people how to use the git bash command line for anybody
Can you put it on a Slack?
Sure, of course I can.
So this is something I would like actually you guys to do. It's not just me. Everybody's learning from each other. I'm learning from you too. So if you find a crazy idea, smart idea that will help people, post it on a Slack.
Just a quick thing. I don't think I was added to your mailing list on the Bronco Direct, so I don't think I was added to your Slack.
Oh, so are you in a wait list?
I was, but I think I got in, which is why I'm probably here now. But
let me see. CPP. If I go here to waitlist, are you there, someone? No.
I am.
Where are you?
I am. It should.
I cannot see in a waiting list, so let's go.
Yeah, no, I'm out of the waiting list. Like I'm.
You're enrolled, right?
Yeah, but I just didn't receive the.
Don't worry, I will fix it. You just what someone. So, you are.
Oh yeah, I'm right there.
Right.
Yep.
Okay, so what I can do, copy email address. Then I go in the Slack here, and then I add you cancel. Add people. Okay, you're added.
Thank you so much. I appreciate
You're
it.
welcome, sir. Any questions so far? So we have around 8, 15. We have around 23 minutes left, right? I don't want to put too much information, but maybe I can share you something about what this binary system is. Okay, just like for warming up. Okay, so let me get my stylus. Yes, here I found it. Just have 3%. Okay, it doesn't matter. So I'm gonna stop sharing here, and then I will start sharing from my. I'm gonna start sharing from the camera here. 1 second. Stop sharing screen. 1, 2, 3. Okay, and then we're gonna go into the something is called notability. Here is the notability. So we're gonna have a new subject which is called ECE2300 underscore.
Professor, would it be possible you share the notes after class?
I can do that. It's no problem. I can put it under the supporting material.
Okay.
Okay. 2021. Okay, now we're gonna put here 3 to 5. Okay, everybody can see my screen, right? So we have, as everybody know, we have something is called decimal, right? In decimal, as we learn, we have digits, right? So this digit different than this digit, different this digit. So we have here D0, D1, D2, right? This digit, the power of it is 10 power 0. It's because it's decimal. So when I say decimal, look at this. Any number system, it's based on what bases and total number of bases. So the decimal, it has bases 0 to 9. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? How many of those? 10. Right? So if I call this B, so the total is B plus 1. Right? So I have here 10 power 0, 10 power 1, 10 power 2. Right? Example. If I say I have 234 as a decimal, so when I write it, I just put like this, right? I can break it up to what? To 4 times 10 power 0 plus 3 10 power 1 plus 2 power 10 power 2. Let's combine this together. We will find out, this is 200 plus 30 plus 4, which is the 234. That makes sense? So we are talking about integer number without involving fraction, right? So fraction is another story, but for now, we are talking about what? Integer. What about the fraction? So the fraction, you have decimal point, and then whatever is going to be 10 power minus 1, 10 power minus 2, up to 10 power minus n. and here up to 10 power n. That makes sense? So you can apply the same story for the fraction, but let's continue with the integer. Now in the binary, when I say binary, that means I just have two bases. Oh, sorry, I have two roots of numbers. So what is this two roots of numbers? We have electricity, or we don't have electricity. We have 0 and 1. So that means our base is equal b plus 1, so it's equal to. In that case, whatever I have seen here in decimal, it can turn to be like this: b0, b1, b2, 2 power 0, 2 power 1, 2 power 2. There is an equation we can write. What is this equation? It's called weighted system. What does weighted system mean? It means here 2 power 0 times W0, 2 power 1 times W1, 2 power 2 times W2, and so on. Right? Let's have an example. So somebody told you that I have a binary number, and this binary number consists of multiple digits, and this number is like this. So when I put this 2 in front of you, it means whatever inside this box is dedicated as a binary, right? Some books, they write it like this. Notation, but still the same content, right? Same idea. So if I like to read this in decimal, what should I do? I'm gonna use my weighted system. I'm gonna use this in weighted system. Let's try this weighted system and see what is this, right? So I set here 2 power 0 W0, 2 power 1 W1, 2 power 2 W2, 2 power 3 W3, 2 power 4 W4, and you continue, right? So I consider this W. So this W0, this is W1, this is W2, this is W3, this is W4, this is W5, this is W6, and this is W7. So I will say here decimal equivalent is equal 1 times 2 power 0, right? Added to 0 times 2 power 1. Then it's gonna be what? 0 times 2 power 2. Then 1 times 2 power 3. Then 0 2 power 4. Then 5 is gonna be what? 1 times 2 power 5. Then 6 is what? 0, right? 0 2 power 6. Then 1 2 power 7. If I start collecting, I will find this term is 0, this term is 0, and so on. If I add up, I will find the equivalent in what? Decimal. So what I am doing now, I'm converting from a binary to decimal. So let's have it here. Binary to decimal examples. Question number 1. Binary is equal to 10101. What are the decimal form? So in that case, I would say 1 2 power 0, 0 2 power 1, 1 2 power 2, 0 2 power 3, 0 1 2 3, right? And then here 1 2 power 4, 1 2 power 5. Let's continue on this and finish it. So here is 1 added. Here is what? 0 added. here is what? 4. Then, you know, here is what? 0. Then this is what? 16. Then, you know, this is what? 32. Add up all of this together. So gonna be what? 1 plus 4 is 5. 5 plus 16 is 21. 21 plus 32 is gonna be 53, right? So this is 53, sorry, 53 and 10s equivalent to this value in binary. Any questions so far? Let's do the reverse. Somebody give me 53 and I would like to convert it to binary, right? How can I do this? Let's see. So the rule said, if we are an integer, we have to divide by the base. Base, it doesn't need to be binary, it can be whatever, right? So 53 divided by 2. So we're gonna do it multiple times until we reach to the end, which is 1. So every time you divide the decimal by 2, and you will look to the remainder and the quotient and see what is the value will be. Sounds good? So let's do it. So 53 divided by 2 is what? I get my calculator. Uh, 53 divided by 2 is basically it's half plus 26, right? Then this 26, I'm gonna take it divided by 2. So 26 divided by 26 divided 26 divided by 26 divided by 2. So it's gonna be what? It's gonna be 0 over 2 plus 13. Then, you know, 13 divided by 2 is what value? It's gonna be 1 divided by 2 plus 6. Then I will take 6 here, it's gonna be divided by 2. It's gonna be what? It's gonna be 0, 2, 3. Then I will take 3 divided by 2. It's gonna be what? It's gonna be 1.5, right? So then, you know, 1 divided by 2 is gonna be what? Right? Now I'm done. I reached the point which I'm looking for. I want to see this to say I'm done, right? Now what I'm going to do, I'm going to start looking from the up to the bottom and take it from the right to the left, least significant to the most significant, the less important to the most important. So this one, I'm gonna put it here. This 0, I'm gonna put it there. This one, I'm gonna put it here. This 0, I'm gonna put it here. This one, I'm gonna put it here. This one, I'm gonna put it here. And of course, I don't have any more. So if I start looking to this number, I will find that it is the same number as the one in the top. Do you guys agree? Look, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, and 1, and 1. Do you have any questions so far?
Can you go back down a little?
Yes, sir. I can do another example. Do you like me, or do you like to go in this one? Let me do it again. Let me do it again. You know, we are learning here, right? Do you remember when you divide by number, you get two things, right? Remainder and a quotient, right? So I'm dividing by what? By 2, right? So 53 divided by 2, what is the value it is? It will be something with fraction, right? You guys agree? So something with fraction.
Why don't you do from top to bottom?
What do you mean by top of the bottom? You mean like this?
Is it 1, 0, 1?
No, let me tell you something.
Please enlighten me.
I'm you know, here's the thing. Everything in English is from the left to the right, right? But you know, I'm not using here English or a different language. I'm using what is the least significant, most significant. So the number first time it will be divided by the base is giving me the least significant. That makes sense? Look, so 53 is the number. I divided by the base, which is 2 in my case. So that's gonna be what? Half plus 26. Since the base is 2, so I'm looking to the number above the 2. What is the number above the 2 is 1. So I take this number and I consider it the least significant. From where I got this least significant? Do you remember the idea of 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, and so on? This is the least important compared to this. This is least, this is higher, and so on. So, the lower is here, the higher is there. Lower, higher. So it's up to you. Let's say that, someone would decide to read it from the bottom, right? Let's read it from the bottom together, right? Here, 1, 1, 0, 1, 0, 1. So the bottom for me is the most significant. So I read from the right, from the left towards the right. That makes sense? Should I make another example?
Professor,
Yes.
before we go ahead, I just want to make clarify something. When you say so about the base, that means we can use any number. We could have used 4.
Whatever. Yeah, it is.
Okay.
I will give you another example, but not now. Today I don't want to bomb you with a lot of stuff, but at least about it,
Yeah.
I mean, I can finish the whole course in one night if you want. No doubt. It's a piece of cake, but it would be too much. Okay, so let's go for just a binary, right?
Can you show us how to convert the alphabet into binaries?
Oh, it's easy. There's something it's called ASCII code. Have you heard about ASCII code?
No, I've heard about Unicode.
What?
Just,
No.
I've heard about ASCII code.
Just go in the internet and write ASCII code. That's actually one of the things that we're going to discuss about and by the end of chapter 1. So ASCII code is American something standard. In a way that, when I push A, is it lowercase or uppercase, it will turn to be 7-bit. And when I say bit, it means that 7 digit, and each digit is described in 0 and 1. Make sense? So let me show you, for instance, if I stop sharing here, no. Okay, I stopped sharing. Then, I will share back here my screen and I say share. Then I will just go here and say ASCII code table. Look at this. Did you see that? If you write 0 in the keyboard, that actually gonna be written in the computer. Bunch of zeros. When you group it, it will be octal and hexa, and I will tell you later what is this. And you will move forward up to characters, and so on. Did you see this A and B and R? You will find it somewhere here. Here's the special characters. Did you see those special characters? A, for instance, look. Did you see my cursor? Can you see my cursor? A, when I push it in the bottom, that will be the value written there. Which is basically be sure while you're in a binary, I like to read it from the least important to the most important. So, one bunch of zeros and 1 0. Can I ask you a question? If somebody tell you my decimal number in my hand is 035 from the left to the right, so how can you read it? It's gonna be 35, right? Because any zeros in the most significant will be what? Neglected. That makes sense? Any question?
Sorry, you said if you read it from the left and you can you repeat the last portion again?
Yeah, I'll show you. One second. Stop sharing. Let's go back to the sharing. Screen. Perfect. Let's go here. Okay. Now look, if I write here 10101100000, this one is equivalent to that one. Is it correct?
Yes.
You know, yeah, because the rest here is gonna be whatever power times 0. Right? So imagine like the following. If I have a number like this, I have a decimal point and have a number like that, right? If I put here any zeros in the left, useless for me. It will not affect, right? If I put here zeros also, it's also useless for the fraction, right?
Mm-hmm. Yeah.
That's basically what I'm saying. So I can give you maybe another example and then, we'll be done, okay? So for today at least. So let's say 64. I would like to convert 64 to binary. So I'm gonna do what? 64 divided by 2. It's gonna be what? 32. So it's gonna be 0 power 2 plus 32. Then I will take 32 divided by 2. It's gonna be 0 by 2, and then 16. Then 16 divided by 2, it's gonna be what? 0, 2 plus 8. Then 8 divided by 2, it's gonna be 0, 2 plus 4. Then 4 divided by 2 is gonna be 0, 2 plus 2. Then 2 divided by 2 is gonna be 0 divided by 2 plus 1. Then 1 divided by 2 is equal what? Half plus 0. Right? Now let's read it as I said from the bottom, from the top to the bottom. So gonna be 1, 2, 3, and then number 4 here, and then number 5 there, and then number 6 there, and then 1 here. So this one equivalent to the 64. Sounds good?
Yep, sounds great. Thank you.
What is the key? What is the key thing here? Practice. As much as you practice, as much this will be a piece of cake. And
How soon will these recordings be up? How soon will these recording lectures be up on the folders?
Today.
Okay.
So today, by end of the day, I will collect all of this recorded stuff and I will put it on what? YouTube, and I will put the link there. Okay?
Okay.
Sounds good? I'm gonna repeat this actually again on the next lecture.
All right.
Okay, guys. So I want to thank you for attending the first class for the 2300 spring 2021. And I hope all the best to you guys. As I mentioned to you, it's really quite easy course. I don't want you to panic, and I promise it's really easy. You just need to work a little bit, okay?
Thank you, sir.
So for the book, how much are we supposed to read from the book?
The book.
Oh, the book, yeah. There's like infinite books, right?
I have a news for you. There is infinity plus 1 books.
Well, I mean, are we just supposed to show up for lecture and just watch, or is there any chapters for the book that we have to read? Or
Just
You don't need, I mean, if you want to read before you come to me in the shop in the class, that's fine. If you want to read it after that, also it's fine. It's up to you. But I would recommend to listen to the lecture first, and then you can read, so it will be much easier for you.
Okay, so all the material will be coming mostly from you. That'd be great.
Okay, guys. And also, sometime I will, while I'm in the lecture, I will just open the Morris book maybe, and I will just pick up some examples or problems, and I will solve it in front of you. Okay.
Okay. Thank you.
You're welcome. Any other questions? So God bless you guys. Stay safe. And the most important, stay safe. Okay. God bless you. And I'll talk to you on Wednesday. See ya.
Bye. Thank you.
See you. Thank you, sir.
Thank you, Professor. Have a good day.
You too. Thank you.